Hello, hello. Next chapter. Let's go. Processes and system calls. Breaking boundaries. Thanks, Ted. Since you taught me how to make system calls, I haven't looked back. Ted? Ted? Are you there? It's time to think outside the box. You've already seen that you can build complex applications by connecting small tools together on the command line. But what if you want to use other programs from inside your own code, like call external programs? In this chapter, you'll learn how to use system services to create and control processes. That will give your programs access to email, the web, and any other tool you've got installed. By the end of the chapter, you'll have the power to go beyond C. System calls. System calls are your hotline to the operating system. C programs rely on the operating system for pretty much everything. They make system calls if they want to talk to the hardware. System calls are just functions that live inside the operating system's kernel. Most of the code in the C standard library depends on them. Whenever you call printf to display something on the command line, somewhere at the back of things, a system call will be made to the operating system to send the string of text to the screen. So a system call is just like an API to the operating system. It allows your program to invoke things that it would normally not be able to. The Your program will basically tell the OS based off of some function call that the OS provides to do that thing. So in this case, print something to the screen. So your program is, I want to display this on the command line, then play this music track, then send this message to the network. The computer goes, certainly, I shall perform those tasks immediately. Let's look at an example of a system call. We'll begin with one called system. So that's like the catch-all, I guess. System takes a single string parameter and executes it as if you had typed it on the command line. Oh, okay. So it's like literally taking whatever you put in here and pretending like it's shooting it through to the terminal. Okay. So it looks like this one is for Windows. This one is for Linux. And this one's on the Mac. Okay. Uh, the system function is an easy way of running other programs from your code, particularly if you're creating a quick prototype and you'd sooner call external programs rather than write lots and lots of C code. Okay, so since the system function takes in an argument that would normally be just passed through the terminal, you can actually call other programs that way. That's like the most basic way to do it. So I can make a program, a quick one. It looks something like this. Let's see, system demo one. Just have C. Have include stdio.h, main, int argc, character pointer argv, and here return 0. And I think all it is just going to be system, and then echo hello world. Okay, and then let's see if we can compile. Oh, I know why. We were missing a header file. I'll spoil it. I think it's going to be called unistd.h. See what happens. Nope, not yet. stdlib? Oh yeah, let's do this. Man system. stdlib. Okay. Let's do it. GCC. There we go. So it executes echo hello world, just like that. So I wonder what happens if we do something like this. Let's do. Let's execute Firefox. What happens? What happens? Oh, nice. Okay, so it's a super easy way to execute other programs. That's cool. Okay, anyway. A system function is an easy way of running other programs from your code, particularly if you're creating a quick prototype and you'd sooner. Okay, yeah, so that's what you just read. All right. Code magnets. This is a program that writes timestamped text to the end of a log file. It would have been perfectly possible to write this entire program in C, but the programmer has used a call to system as a quick way of dealing with the file handling. See if you can complete the code that creates the operating system command string that displays a text comment followed by the timestamp. Okay, so this one returns a string containing the current date time. So operating system command string that displays a text comment followed by the timestamp. Okay, so we'll have a helper here that will give us back the timestamp, and then we're going to write the code here. Let's write the code. Ah, system demo 2. How do I collapse this? Control Shift E. This Control Shift, Control Shift, Control Shift, Control Shift E. Huh? Weird. Alright. SDIO.h include SDIO.h include time.h. We'll have char star now. Time t time ampersand t return time ampersand t. So that's our helper function. That will return us, I guess, the string that represents the local time in this form. Day, month, and then what is this DD? Oh, day as in like Monday, Tuesday, Wednesday, Thursday, month, number, hours, minutes, seconds, year. Okay. Okay. Now it's going to be character comment 80. So as a buffer and a command. Okay. Let's do it. So first, I know that we're gonna need one of these things here, but we also need to get this now string. So we're gonna have to have like a char star now or something like that passed in. I think that's fine. So most likely it's gonna be here, echo, blah blah blah, and then the two strings that follow it, and this will probably like be a printf of some sort. Not sure what these are though. This is a big one right here. Maybe this is the print. One of them is gonna have to be like a CMD because this one says CMD here. So should we then just say system? One of them is system. Okay. It's really hard when you do it this way. Alright, let's just do it. What are we trying to achieve? Okay, so we want to basically load up. We want to build up a command that will get executed, okay? And I believe this will be the command that gets executed. So then what we want to do is, I think it's F, S print F, S print F. So what is the parameters? There should be 4, yes? 1, 2, 3, 4. So what is this one? Is this the, what is this one? Let's take a look at it. S print F, S print F, S print F. Hey, come on. So one of them has to be SCD, and I just forgot what order it is, I guess. Let's see. I'm already struggling. That's not good. The functions in the printf produce output according to format as described below. The functions printf and vprintf write output to SD out, the standard output stream. Fprintf and vfprintf write outputs to given output stream. Sprintf, okay, write to the character string stir. All right, what is stir? Stir. That's printf. Stir. So that's an output. That's going to be CMD, and this is going to be the format. Okay, we're getting somewhere. Yay! So this will be the output we want to output into command, and then basically the format string is going to be this. Percent %s, %s. So that's exactly, we're going to build our command like this. Okay, and then comma. Now it's going to be what? The 2 strings that we need, which is going to be, I guess, one of them has to be now, and the other one has to be what? Text comment. So the comment itself is the first one, and then now will be the time, like that. Okay, so that's 1, 2, 3, 4. That's this one, this bottom one here. But what about this one here? I think that's for the comment, huh? So that displays a text comment. Okay, so they did. I think the requirements didn't tell us where the comment is coming from, but I'm guessing now it's from just standard in, maybe. So let's do f get s, and then this one will be, what is it? Comment, and then we're gonna get, I guess, 80 characters, and then stdin. Okay, and then we'll just do this, and then we'll call system command, and that should be it. So we declared a buffer called comment that will receive, essentially, I guess when we use this program, we'll input whatever comment we want into this comment buffer, and then we'll call sprintf to generate this command here with our inputted comment, and then a call to now here that would give us the time, the date time. All that is going to be built and then thrown into this command buffer, and then at some point we're going to have it all nicely formatted, and we're just going to use system to call it literally. So then we can just say maybe some logging here, printf or actually let's do this. Yeah. The command to be run is %s, and then we'll do cmd here, and then we'll just call it. Okay, let's do it. Then we'll just do cd system demo2, gcc and I hope all that construction outside get picked up. Hello? Oh. Hello? Okay. The command to be run is echo hello Friday blah 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 reports.log. Okay. Did that go in? Let's see. Reports.log, cat reports.log. Okay, it did echo all that. Good. So let's see. So fgetS, comment 80, scdn, sprintf, cmd, echo, comment now. And then it should be something like this. Checked in from a compound interest program, okay, and then the date, and blue leader reports breach in jet walls, okay, and this. Okay, cool. We got it. So the program worked. It read a comment from the command line and called the echo command to add the comment to the end of the file. Even though you could have written the whole program in C by using system, you simplified the program and got it working with very little work. There are no dumb questions. Okay, so you can't pick up the construction. I don't see the audio levels going. Great. Okay. Does a system function get compiled into my program? No, the system function, like all system calls, doesn't live in your program. It lives in the main operating system. So the implementation of system is in the OS. It just basically when you include, it'll just include the header. Like when you include the header, it'll just include like I guess the pointer to that function call. Yeah. When I make a system call, I'm making a call to some external piece of code, like a library, kind of, but the details depend on the operating system. On some operating systems, the code for a system call lives inside the kernel of the operating system. On other operating systems, it might simply be stored in some dynamic library. Depends on the OS. Yikes. Then someone busted into the system. There's a downside to the system function. It's quick and easy to use, but it's also kind of sloppy. Before getting into the problems with system, let's see what it takes to break the program. The code works by stitching together a string containing a command like this. Echo, and then the comment, and the timestamp, and the output reports.log. But what happens if someone entered a comment like this? Echo, okay, single quote, and ls over, I guess over, it's not, and echoes, single quote, and then the timestamp, and then, okay, so they're probably using some sort of weird exploit. By injecting some command line code into the text, you can make the program run whatever code you like. Ooh, let's try it. So let's do this. Echo. Wait. So we do this. A.out, I guess. And then we're gonna receive input. So we can do echo. Wait. Oh, this is a comment. Ah, I see. I'm getting confused. So the comment we want to put is this. Okay. If we do that, oh snap. The reports.log is the command is going to be all of this really. Echo, empty string, okay. So that will give us back an empty string, and after we're done echoing this empty string, we're gonna ls, and I don't know what the slash means. Oh, ls root. Oh, ls root. Okay, and then and echo all of this stuff like normal. Oh, then basically what ends up happening is that they can execute weird commands like listing our entire root directory. That's crazy. By injecting some command line into the text, you can make the program run whatever code you like. Huh. Is this a big problem? If a user can run guard log, she can just as easily run some other program. But what if your code has been called from a web server, or if it's processing data from a file? Yeah, so like if your program is generating HTML, for example, based off of some like input like this, and then you're like dash or redirecting all this output here into a reports.log or like a reports.html, and you send that HTML back, you can be leaking a lot of information. So maybe it's in here. No, not in this case. Wow. Okay. Security is not the only problem. This example injects a piece of code to list the contents of the root directory, but it could have deleted files or launched a virus. But you should just worry about security. What if the comments contains apostrophes? That may break the quotes in the command. What if the path variable causes the system function to call the wrong program? What if the program we're calling needs to have a specific set of environment variables set up first? Oh, that's a lot, because you need environment variables and you have to do a bunch of other stuff. The system function is easy to use, but most of the time, you're going to need something more structured, some way of calling a specific program, with a set of command line arguments and maybe even some environment variables. 8 bits. What's the kernel? On most machines, system calls are functions that live inside the kernel of the operating system. But what is the kernel? You never actually see the kernel on the screen, but it's always there, controlling your computer. The kernel is the most important program on your computer, and it's in charge of 3 things. First, processes. No program can run on the system without the kernel loading it into memory. The kernel creates processes and makes sure they get the resources they need. The kernel also watches for processes that become too greedy or crash. Memory. Your machine has a limited supply of memory, so your kernel has to carefully ration the amount of memory each process can take. The kernel can increase the virtual memory size by quietly loading and unloading sections of memory to disk. And finally, hardware. The kernel uses device drivers to talk to the equipment that's plugged into the computer. Your program can use the keyboard and the screen and the graphics processor without knowing too much about them because the kernel talks to them on your behalf. System calls are the functions that your program uses to talk to the kernel. And we can say like the kernel is kind of like just, we can group, I guess anonymously, we can just say kernel operating systems are the same thing. There's a lot more to it, but we can just treat it this way as normal programmers. We'll go more into detail, I guess, one day. Maybe one day write our own OS, probably. Hint, hint. The exec functions give you more control. When you call the system function, the operating system has to interpret the command string and decide which programs to run and how to run them. And that's where the problem is. The operating system needs to interpret the string, and you've already seen how easy it is to get that wrong. So the solution is to remove the ambiguity and tell the operating system precisely which program you want to run. That's what exec functions are for. So don't just run any arbitrary string as if you typed it into the terminal, but run a specific program. Have a function call to invoke a specific program and its arguments as separate arguments to that function, and that function is called exec. The exec functions replace the current process. A process is just a program running in memory. If you type taskmgr on Windows or ps-ef on most other machines, you'll see the process running on your system. The operating system tracks each process with a number called the process identifier, or PID. The exec functions replace the current process by running some other program. You can say which command line arguments or environment variables to use, and when the program starts it will have the exact same PID as the old one. it's like a relay race where your program hands over its process to the new program. Whoa, wait. So the exec functions replace the current process. So when you when you call the exec function with like the name of your new program that starts up will replace your current program because they'll have the same PID. So that code, so that uh, just think of it like moving that code of that program into, I guess, where that code is currently of your running program, or maybe it like repoints the program counter somewhere else. And I guess that's a like I know it's more nuanced. Okay, well let's not think about that right now. Okay, I'm handing over to you now, said Mail. This is the data you need. Don't let me down. I'm all over it. A process is a program running in memory. Okay. There are many exec functions. Over time, programmers have created several different versions of exec. Each version has a slightly different name and its own set of parameters. Even though there are lots of versions, there are really just two groups of exec functions, the list functions and the array type of functions. So we'll have these list functions called exec-L, exec-LP, and exec-LE. The list functions accept command line arguments as a list of parameters like this. First, the program, the name of the program. Okay, this might be the full path name of the program, exec-L or exec-LE, or just the command name to search for, exec-LP. But the first parameter tells exec function what program it will run. Next is the command line arguments. Okay, that's right. After you need to do the command line arguments. You need to list one by one the command line arguments you want to use. Remember, the first command line argument is always the name of the program. So if we look at here, it's the name of the program, and then again, list the name of the program. Okay. That means the first two parameters passed to a list version of exec should always be the same string, pretty much. It's the name of the program, and then all your other arguments here. And then, that's right, at the end of it all, you just put null. That's right, after the last command line argument, you need a null. This tells the function that there are no more arguments. Environment variables, maybe. If you call an exec function whose name ends with a exec LE, for example, okay? I'm guessing there's like an exec V vector for the array type. Let's see. If you call an exec functions whose name ends with an ... E, you can also pass an array of environment variables. So E, I guess, stands for the environment variables. This is just an array of strings like power equals 4, speed equals 17, port equals open. So it's like this whole, export port equals 3000. Then we could just do echo port. Same type of environment variable that we would have passed in shell. Okay. So here's exec L. So same thing, like the program name twice and then all the other parameters to the program. And then end it with null. Exec LP, I guess, would, I guess, a list of arguments to search on the path. Don't know what the difference is. Looks the same. Oh, it assumes that you have this program already defined in your path variable. Okay. But it's the same thing as exec-L. But the exec-LE is different. It's the same, same program name twice again. All the command line arguments. Finally, the null to signify to stop processing the command line arguments. And then the list of environment variables. Environment variables is an array of strings containing environment variables. Ooh. Okay, so the array functions exec v, exec vp, and exec ve. If you already have your command line arguments stored in an array, you might find these two versions easier to use. Oh, okay. So instead of passing in the arguments like one by one, we just store them in an array and pass them in as the array. Okay. Cool, cool. Got that. So exec v, exec vp are again similar to the pattern found in exec l and exec lv. Uh, yeah. This one, the L LP, yeah. This VP one will say this is should be found in the path. Okay. Okay, so the only difference between these two functions is that exec VP will search for the program using the path variable as opposed to the absolute value. Okay. So how to remember the exec functions? I guess you don't. I think we just look it up. I'm guessing. I think you should. I mean, memorizing these types of things aren't really fruitful. I think just know the gist. Okay, you can figure out which exec function you need by constructing the name. Each exec function can be followed by one or two characters that must be LVP or E. The characters tell you which feature you want to use. So for example, the exec LE function will first call exec, looks like the list of arguments and the environment variables. And the L and V characters always come before P and E. The P and E characters are optional. As in the function name, I'm guessing. Yeah, the function name. Okay. So all exec functions begin with exec, takes in a list of arguments, and also takes in a vector of arguments. You can also specify whether or not to search for the path to run the program or give it the absolute path. And then you can give it an environment variable depending on which one you call. Cool. Yeah, I think I'll stop here.